Welcome to this explainer. Today, we're diving headfirst into the great Martian mystery. We are going to unpack the dramatic and, frankly, mind-blowing transformation of the fourth planet from the Sun. We'll track its unbelievable journey from a vibrant blue ocean world that might have harbored life straight through to the barren, red desert we know today.
And that brings us to the ultimate cosmic mystery, right? Could this freezing, toxic red desert actually have been a vibrant, watery world? It's kind of hard to wrap your head around when you look at it now. How exactly does a whole planet just lose its oceans? Where did all that atmosphere go? And the biggest question of all, did life ever get a chance to spark before the water dried up? Well, let's look at the data we've pulled from decades of exploration to find out.
Act 1. The Red Desert. Let's start with what we see today.
So looking at Mars right now, it is a beautifully hostile environment. It isn't just a mini Earth, it's a completely different beast. It's about half the size of our planet, which means you'd only experience about 38% of Earth's gravity there. But the real shocker is the climate. While we're sitting at a cozy global average of about 59 degrees Fahrenheit, Mars is at a bone-chilling negative 85 degrees. Plus, because of its tilted axis and elliptical orbit, its seasons are absolutely extreme, and they last almost twice as long as ours.
Now, you really can't talk about Mars without talking about that iconic color. Why is it so red? Well, basically, the whole planet is covered in rust. The surface is completely blanketed in this loose dust and rock we call regolith. And this regolith is just packed with iron-rich minerals. Over billions of years, these minerals oxidized, which, is just the scientific way of saying they rusted. That fine, rusty dust gets kicked up into the thin atmosphere and literally paints the entire world that signature reddish-orange.
But don't let the word desert fool you into thinking it's quiet. Mars has incredibly violent, dynamic weather that would instantly doom an unprotected human. For starters, you've got an unbreathable atmosphere made of 95% carbon dioxide. Then you add in these towering, spiraling dust devils, massive dust storms that can literally engulf the entire planet for months, and get this, clouds that actually drop carbon dioxide snow. Sprinkle in some of the most extreme geological features anywhere, like Olympus Mons, the largest volcano in the solar system, and Valles Marineris, a canyon so huge it makes the Grand Canyon look like a tiny ditch. And you've got a truly wild frontier.
Moving on to Act 2, Mars' ancient blue past.
Here is where we hit the greatest plot twist in planetary history. Mars wasn't always this harsh wasteland. Billions of years ago, before its core cooled down and its magnetic shield vanished, it was actually a warm, wet world. Going back roughly 4.5 billion years, it had a thick atmosphere and an active magnetic field, a lot like Earth does today. Fast forward to about 3.8 billion years ago, during what's called the Noachian period, and the planet was covered in flowing rivers and deep lakes. But then, total tragedy. The planet's molten core cooled off. That shut down its magnetic dynamo, and without that protective shield, the whole environment collapsed into the hyper-arid desert we just talked about.
So what actually happened to all that water? Well, without a magnetic field, these incredibly energetic solar winds just bombarded the planet and essentially blasted the atmosphere away. As the atmospheric pressure totally plummeted, the water either froze underground or just evaporated straight into space. In fact, when scientists compare ancient meteorites with current atmospheric data, they estimate that Mars lost at least 87% of its original water to the cold void of space. 87%. But think about what it was like before it dried up. Scientists believe a massive primordial ocean called Oceanus Borealis covered roughly 36% of the entire planet. Just take a second to really imagine that. That is a body of water holding more volume than Earth's entire Arctic Ocean, covering nearly the whole northern hemisphere of Mars. It was genuinely a blue planet. And the crazy part is, the proof is right there in the dirt. It absolutely blows my mind that places we are currently exploring, like Gale Crater, were once ancient freshwater lake beds. We have found redox active metals, things like iron and manganese, perfectly preserved in ancient ripples of mud. Here on Earth, environments exactly like that have neutral acidity and low salinity. They're practically begging for life to spark. The conditions on Mars were absolutely perfect for microbial life to thrive. Which brings us to Act 3, the robotic search for life.
Because we can't go there ourselves just yet, we've sent robotic detectives to comb through this cosmic crime scene for clues. And these machines are incredible. They've completely changed how we understand Mars, proving that the raw ingredients for life survived the harsh regolith.
You've got the Curiosity rover driving around Gale Crater finding organic carbon. You've got Perseverance out there right now drilling specific rock cores to hunt for ancient biosignatures. And of course, we absolutely have to mention Ingenuity, the little helicopter that hitched a ride and pulled off a staggering 72 flights in an atmosphere that barely even exists.
So what are they finding? Well, while it's not definitive proof of ancient alien life yet, discovering these organic molecules confirms that the fundamental building blocks of life are perfectly preserved right there in the Martian mudstone. Using some seriously advanced chemical techniques, our scientists have identified 21 distinct carbon-based molecules in clay-rich sedimentary rocks, including long-chain hydrocarbons. These complex structures have survived intense radiation and freezing temperatures for literally billions of years.
Astrobiologist Dr. Michael Tice hit the nail on the head when he pointed out that studying how these compounds vary can tell a story of how life and environments changed. These rocks act like a pristine time capsule. Since Mars's surface has essentially been frozen in time, unlike Earth, which is constantly recycling its crust through plate tectonics, these organics could show us prebiotic chemistry. We're talking about a chemical record from before life even began, something completely erased here at home. Mars might literally hold the universal blueprint for how life starts.
All right, let's head into Act 4, Surviving the Martian Frontier.
To truly prove life existed, roaming robots just aren't enough. We need to get those rocks into our most advanced laboratories here on Earth. So, NASA and the European Space Agency are putting together this completely unprecedented, multi-step mission called Mars Sample Return. The plan? Land a retrieval platform on Mars, take those sample tubes Perseverance has been dropping, load them into a small rocket called the Mars Ascent Vehicle, blast that rocket into Martian orbit, catch it with another spacecraft, and fly the whole shebang back to Earth by the late 2030s. It is easily one of the most ambitious robotic missions we have ever dreamed up.
But as we start looking past the robots and towards sending actual human astronauts, we have to face a pretty brutal reality. The planet actively wants to kill us. As we covered, the air is unbreathable, the temperatures are freezing, and there is no magnetic field to stop heavy cosmic and solar radiation. Oh, and the sneakiest danger? The Martian soil itself is packed with toxic chemicals called perchlorates. Anyone stepping foot on Mars is going to face a months-long journey just to get there, followed by incredible engineering hurdles just to survive, let alone build a permanent colony. So I'm going to leave you with this final thought. As we uncover the massive tragedy of Mars' ancient past, seeing how a beautiful, wet, potentially habitable world was just stripped bare by the cosmos, we have to wonder, do we have the ingenuity to rewrite its future? Can we actually brave the radiation, the toxic dirt, and the extreme cold to make this red desert humanity's second home? It is without a doubt the ultimate challenge for the next generation of explorers. Thank you so much for joining me on this explainer. Keep wondering, keep learning, and I'll catch you next time.